Having in mind a catastrophic failure caused by over-reinforcement due to its brittle failure, it becomes important for us to check the reinforcement ratio at site in order to determine whether our section is over-reinforced, moderately reinforced, or under-reinforced. Of course, it is better to have our section under-reinforced than the otherwise. Hi, I am Ushibe, and today I shall be teaching you how to check for over-reinforcement in a column. Welcome, stay tuned. What is reinforcement ratio? Reinforcement ratio is the ratio of the area of steel to the area of concrete. So, the maximum allowable reinforcement in a given section of a column is 6% of the gross cross-sectional area of the concrete. The minimum is 1%, while the maximum at lapping point is 10%. So let's get down so we can get more explanation and detail by tracking one example here. We've been saying all this while that the maximum or the minimum reinforcement allowed in the section of a column is 1%, which must be less than or equals to the reinforcement ratio, which must be less than or equals to area of steel all over area of concrete, which must be less than or equals to 6%, 0.06. This is for normal section. Then if it is the lapped section, we're going to have 0.01, which is less than area of steel all over area of concrete, which must be less than equals to 0.1. This is for lapped point, the lapping point. This is the maximum. The maximum allowable here is 10%. So let's quickly have an example so we can understand this better. So your column to be moderately reinforced, it must fall between 0.01 to 0.06. Anything above 0.06 is over reinforcement. Anything below 0.01 is under reinforcement. For example, if we have a section like this, if we have this section, we have 0, 0, 0. We have this section. So assuming from here to here, it's 45 mm. Then here, from here to here, is 45 mm. So how do we know whether this section is over reinforced or under reinforced? So what we do is we have to get the reinforcement ratio. We have area of steel all over area of concrete. So area of steel now equals to pi d squared all over 4, then times the number of bars. So here we have how many number of bars? We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, assuming this is 8y20 and this is 8y20. So what do we do now? We now say to get this, we have pi times d. Our d is the diameter of the bar, which is 20. So we have 20 squared times the number of bars, which is 8 all over 4. So when you do this, you are going to have 20,000. You are going to have, when you multiply this out, you are going to have 15,000. This is what you are going to have, millimeter squared. This is the area of your steel. Then if you also get area of concrete, which is equals to the area of this square, which is 450 multiplied by 450, which will give us 2250 millimeter squared. So our reinforcement ratio is equals to area of steel, which is 15,086.4 millimeter squared all over area of our concrete, which is 2250 millimeter squared. So this divided by this. Once you divide this, you are going to have that this is equals to punch it out, you have 0.745. From the look of things now, you find out that this is above our 6%. And it is above our 6%. So this simply means that this section here is over reinforced. Let's quickly take another example. So if we have a section, like this, we have 1, 2, 3. We have a section like this. Let's say this is a 300. This is 300 mm. So this is 6/16. So to get our area, reinforcement ratio, we have what we have here. We have 6 times 16 times 16 times what? Pi all over 4 all over area of this, which is 300 times 300, which all in millimeter squared. So if you cancel them out, you are going to have that your aspect ratio is multiply this out, you are going to have 0.054. So if you look at this and check our aspect ratio, which says that 0.01 must be less than or equals to our aspect ratio, which must be less than or equals to area of steel all over area of concrete, which must be less than or equals to 0.06. If you check this out, you find out that this falls in between 0.01 and 0.06, showing that this is moderately reinforced. So this section here is moderately reinforced. So if you have any question, quickly go to the comment section and drop the question. I will be there to reply you quickly. Thank you for watching this video, and don't forget to subscribe and click the notification button for more of videos. Thank you very much.